Hello everyone, welcome to your Tutors AM, and in this video we're going to be looking at oxidation and reduction, and then we're also going to be looking at a little bit on oxidation number. So a substance is oxidized. This is one definition of oxidation: when it gains oxygen, hence oxidation. So let's say we have magnesium, um, Mg. Then let's say magnesium reacts with oxygen gas, with O2. Then the products that are going to be formed, that is obviously magnesium oxide, magnesium oxide with a 2. Oh, sorry, magnesium oxide, just magnesium and oxygen. So let's just balance this this chemical equation by putting a 2 here and another 2 here. So we can say that magnesium has been oxidized due to the fact that it has gained oxygen. So we can say that magnesium has been oxidized. So oxidation can be defined as the gain of oxygen, and then oxidation can also be defined as the loss of hydrogen. Let's take it let's take we have ammonia. Let's say we have ammonia 2. This is let me just let me just give an example. Let's say we have ammonia. So ammonia, let's say ammonia has been decomposed. Ammonia has been decomposed into nitrogen 2 and hydrogen. (3H2). So we can say that ammonia has been oxidized due to the loss of hydrogen. Yeah. So what is the main concept behind oxidation? A substance is oxidized when it loses electrons. So once something loses electrons, once a substance loses electrons, we can say it has been oxidized. It has been oxidized. So now reduction is basically the opposite of oxidation. So in reduction, we we know that oxidation is a gain of oxygen, so then reduction could be the loss of oxygen. So let's just look at a simple uh, reduction reduction formula where oxygen has been lost. Let's say you have copper oxide. I do not know what's happening to my mouse. Let's say we have been given copper oxide. Sorry for that one. Oh, we do. Let's say we have been given, my mouse pad is very rough. Let's say we have been given copper oxide plus hydrogen gas, So then the products that are going to be formed in this reaction will be just copper and water. So we know in this reaction we have seen that copper has lost oxygen, hence it has been reduced. So this is another reduction. Now, uh, when a substance also gains hydrogen, it can be reduced. So let's say we have uh, 8. The chemical equations that I have are already balanced, so do not mind the numbers. The numbers are just showing that they are balanced. Plus is 8, and then this goes ahead and forms This is sulfur reacting with hydrogen. So we can see that in this reaction, sulfur has gained hydrogen, hence it has been reduced. So now let's go ahead and look at oxidation at the oxidation number. So one thing that we have to understand before we look at the actual oxidation number is that when we have been given a pure element, let's say iron, Fe, the charge of iron here is 0. Iron has got a charge of 0. That's one thing that we need to understand. And then let's say we have been given oxygen. So the oxidation number of oxygen is 2 minus oxygen. Well, it's similar to the valency number. So this is oxygen. So implying that it has got an oxidation number of minus 2. Not 2 minus, but minus 2. Yeah. And then one thing that we also have to understand is that the oxidation number of a free element is 0, and the oxidation number of hydrogen is +1, except in metallic hydrates. And then the oxidation number of a simple ion is equal to the charge of the ion. The total of all the oxidation numbers of the elements in a compound is 0. So let's say we have been given nitrate, NO3, and then let's say they want us to calculate the oxidation number of nitrogen. So we know that the oxygen in this scenario has got a charge of 2 minus. So oxygen has got a charge of 2 minus. So if we're going to write this in form of oxidation number of nitrogen, we can write nitrogen, which we do not know the oxidation number of, and then it's always going to be plus. And then we know that the oxidation number of oxygen is, we know that the number of atoms of oxygen here is 3. So we have got 3 atoms of oxygen, that's not 0, that is O, and then have to give us, and then this is a compound. This minus 2 is for oxygen. So in form of a compound, we know that the net charge is 0. So we're going to have 0 this side, and then we're going to have N. It's just simply going to be like an equation plus 3, and then oxygen has a charge of minus 2. We know that that is the charge that it's going to give out. So N will be 3 times 2, which is minus 6, being equal to 0. So now N will be equal to 1 6 crosses a equal sign, it will be plus 6. So implying that the charge of nitrogen is plus 6, because now here once you have three oxygen atoms, that's going to be 3 times the charge of oxygen, which is minus 2, which is 6. Then the net charge of the whole compound has to be 0, because here we have plus 6, and then here we're going to have a minus 6. Let's go ahead and try out another example. Let's say we have been given ammonia, NH3. Let's say this is what we've been given, and then we know that the charge of hydrogen is minus 1. So hydrogen has got a charge of minus 1. So we're going to have N. The charge is the same as the valence, so not per se valence as in the combining power, but we have to relate it to the ion. So we have to know the charge of of a specific element as an ion. So in this case, we are solving for nitrogen again. So we're going to have plus. We have 3 atoms of hydrogen. So that's going to be plus 3. And then we know the charge of hydrogen is minus 1. When hydrogen is reacting when hydrogen is reacting with a metallic when hydrogen is reacting with a metal, its charge is minus 1, and when it's reacting with a non-metal, its charge is plus 1. So we know nitrogen is a non-metal, so this should be plus 1. So this will become nitrogen, and then this will become plus 3 is equal to 0. So then the charge of nitrogen in this case will be minus 3. Yeah, so that's basically how we solve for the oxidation number. Let's just have another quick example. Let's say we have been given methane CH4, and then now they want us to solve for the charge of carbon. So you know carbon is a non-metal, so hydrogen will have a plus 1 charge, so that will be C plus. Hydrogen will have a plus 1 charge, so that will become 4 plus 1, which is just 1. And then the net charge is 0 for a compound unless we have been given the charge of the methane. That's when we are going to put another number. So this will have carbon being equal to minus 4. And then we know carbon can lose 4 electrons to be stable. Yeah. So the whole concept, let's just try another one, except this one will be kind of different. Let's say magnesium chloride. So let's say we have been given magnesium chloride. Magnesium chloride. So if we have been given magnesium chloride, what we simply have to do is at first we can simply write it as an equation, which is Mg plus, we have got 2 atoms of chlorine, so which will be 2Cl. The net charge is 0. The net charge is 0. So this is going to be Mg. We're solving for magnesium. So we know that chlorine is a halogen. It is in group 7. So implying that the charge of chlorine is minus 1. So we're going to put 2 and then it will be multiplying negative 1, the charge of chlorine being equal to 0. So magnesium will be equal to this will become negative 2. Once negative 2 crosses the equal sign, that will become plus 2. So then the charge of magnesium in this scenario is plus 2. Let's try let's try out another example. Let's try to solve for aluminium fluoride and see if we can find the oxidation number of aluminium in aluminium fluoride. So let's say we have been given Al F3. Al F3. Let me just write my F3. So aluminium. So we're simply going to do the same. Aluminium plus fluorine. Fluorine is in group 7. It's a halogen. So we know that since it's a halogen, it's going to have a charge of minus 1. And then here we have 3 atoms of fluorine. So it's just going to be 3 times the negative 1, the charge of fluorine. And then the overall charge is 0. So we're going to have Al being equal to that to become negative 3. Once it crosses the equal sign, it will become plus 3. And then we know that aluminium is in group 3, implying that it loses 3 electrons, which give it a positive charge for it to be stable. So let's just go through the last part of oxidation and reduction, which is determining whether which is when we are given a redox reaction, which is a reaction of oxidation, which contains both oxidation and reduction, and seeing which substance has been oxidized and which substance has been reduced. So let's say we have been given uh, Fe. Let's say we have been given iron, which is in solid state. It reacts. Iron has been reacted with copper. It has reacted with copper, which has got a 2 plus. So this is copper ion, which is in aqua state. And then the products of this reaction are fluorine, or are iron, iron, which is now in aqua state. But now iron has become an ion with a 2 plus charge, plus copper, Cu, which is now in solid. So from this reaction, using the oxidation number, uh, we can see that iron has gone up from 0 to 2 plus. So iron has been oxidized. Then copper has gone from 2 plus to 0, so it has been reduced. So this was just a view of oxidation and reduction, the main concepts that have to be gotten. So if you have enjoyed the video, please like, subscribe to the channel, and I'll be seeing you guys in the next video. Thank you very much.